Okay, so before we go into heat and the effects of heat and heat energy and how it's transferred, we need to look at different objects around us, solids, liquids and gases, and we need to try and find out what's the difference between a solid and a liquid and a gas. And so here I have a little container with some ice in it, and I have a little container of it with water, with a liquid, and then I have a little container that I filled with gas. Okay, so unfortunately you can't see it, but it's filled with gas. So if we could look at these containers, for instance, for a container full of ice and a container filled with gas, what would the difference be? Okay, so pretend that we have a microscope and we could zoom in really, really close to these objects. We would see our three little containers that look like this. So we've got 1, 2, and we've got 3. And this one would be our ice, this one would be our water, and this one would be our gas. Okay, so if we zoom into this, all three of them, they will all have the same, they will all look like quite similar, because everything on Earth is made up of particles called atoms. So a particle, and we're only going to draw them as little dots. So if we could zoom in really, really close, we'll see that everything around us is made up of these little, tiny little dots, okay, called atoms. And these atoms are always moving. So the pen that I'm holding, if we could zoom in really, really close, we would see that those little particles are kind of vibrating and moving. And the difference between solid, liquid and gas is how much movement occurs within these particles. And remember, movement, you need energy to move. So we'll get to, and that's where heat comes in. So if we look at ice, that's a solid, we would see our particles very close together. So they'd be moving, but they'd be moving really, really slowly. So they'll just be vibrating, they won't be like dancing around, they'll just be standing around, huddled together, very tightly, and only vibrating slightly. Then, when we look at a liquid, if we could zoom into those little liquids, we can see that these particles have relaxed a little bit. So they'd be filled like that. So we've got our particles, they are not vibrating closely like this, they're a bit further apart because they're moving a bit more. Okay, so they have a little bit more energy, so they're moving a little bit more. And then when we get to a gas, that's a full-on party that's happening there. So they're filled up, they are dancing around and going crazy. And because when you go crazy and you're dancing, you need more space. So there's heaps of space between these little particles compared to water and then compared to ice. Alright, so a solid, and anything that's a solid around you, if you can zoom in, those particles will just be vibrating next to each other. If we look at anything that's a liquid, if you look at your coffee or hot chocolate or water, the particles will be moving a bit more, they have a little bit more energy. And then when we look at our gas around us, they are just moving around everywhere. Okay, full on party in the gas section. Okay, so what does that tell us a bit about energy? Ice has a little amount of energy. All those particles are kind of like just huddled up, snuggled. They don't have a lot of energy like you would if the day is cold outside. You don't have a lot of energy, so you're just going to sit around and watch Netflix. So these ones are just chilling. Then when you give them a little bit more energy, a little bit more lollies, if you eat a little bit more lollies, getting a bit more energy, you'll start moving a lot more. And then this is hyper, when you have heaps of energy and you are just everywhere. Okay, so solids, liquids and gases. So how do I get a gas to become a solid? Can I? Or let's make it easier. How can I get water and turn it back into ice? So I've got my water here. How do I get this back to ice? And the simple way, you would say, is to put it in the freezer. So we need a freezer. But what does a freezer do? So a freezer takes all this energy of the particles, all this water. Remember, the particles have a little bit more energy. But what the freezer does is it takes all that energy away from the particles. It steals them And then when the particles don't have any more energy left, they just huddle together, and that's what ice is. Similar way, if I need to turn ice into a gas, what do I need to give them? Heaps of energy. And how do we give any particle energy? We add heat to it. So we warm it up. So anything that needs energy needs to be heated up.